Hi, my name is Matt Dolan and welcome to this talk on Kotlin fixture tests. The data we use in tests is extremely important, yet we pay little attention to it. Why do we create big test data objects that are hard to read and maintain? Why do we use so many hard-coded values in those objects? And why do we reuse the same test data over and over again? In essence, we are rarely ever testing more than one scenario, often only covering the happy path. Of course, as developers we want to be lazy, we need test data, but we don't really want to have to write and maintain it. I'm going to start by showing how we often manage test data before I go on to demonstrate a technique we can use to improve that. Firstly, it's useful to take a look at a real-world example to get an understanding of what I mean by big test data objects. This is the test data object from Google's IOShed app, which contains over 300 lines of test data setup. While this isn't always a problem, it's impossible to know, looking at this file, what data is needed for what test. Now, to understand how test data grows out of control, we're going to code up some tests using a simple app. Our app simulates a movie database where a movie is made up of properties such as name, director, rating, and a list of cast members, and each of those cast members has a name and a date of birth. And we've got 3 bits of functionality, and these are the bits of functionality we're actually going to test. And that's a display name which combines the name and director, a cast by age which sorts the cast members by youngest first, and a star rating which takes a numerical value and converts it into a string. We already have a test structure in place, so all we need to do is fill in the blanks. So let's start by implementing verify display name. First off, we're going to create a movie. Now I've got a shortcut just to help us out a little bit. And all we need is a simple assertion where we expect the display name to be equal to the movie's director and name combined. Now let's give that test a quick run. And we see that it passes. However, it's worth noting we've hard-coded default values such as empty strings, zeros, and empty lists. So let's put a real movie name in and rerun our test. And now we see that it fails because the movie name and director are in the wrong order. Of course, we don't really know whether our expectation is wrong or our implementation, but we'll assume it's the expectation and switch them over. Rerunning, we now see our test pass again. Next up, we're going to start testing cast by age. First off, we will verify a movie with an empty cast list. We already have a function to check a list of dates is in order, and we'll take it as given that this works as expected. Of course, running this test passes as expected. Looking at the code, we can see movie creation is duplicated, so let's move that into a companion object to create it just once. And running our test suite, we see that both tests still pass. To test a cast of size 1, we again create a movie object with a list of one person. The same assertion as we use in the cast of size 0 can be reused. And running this test, it passes. Now we don't really want to explicitly create a movie object with default values, and a common solution to this is to create a factory function instead of our movie property. Turning the property into a factory function, we can provide a cast parameter with an empty cast list by default. And now, because our property no longer exists, we simply need to update the first two tests to use our factory function instead. Running the test suite, all our tests still pass. Testing the case for a cast of 2 is similar to that of 1, so we'll copy that as a base and add a second person. For the date of births, I've got some local properties set up, so I'm just going to use those for ease. And again running, this test works as expected. Similar to movie, we don't really want to create person objects directly, so let's add a factory function for that with a parameter for the date of birth. Using this factory function, we can see our test code is relatively simple. However, the problem is these factory functions don't scale well, and it is easy to imagine having parameters for every property of those classes as you build up a more complete test suite. Of course, another approach for test data is to use mocks. However, as before, we still need to hardcode data, and often we end up having to mock data that is not directly related to what we are testing. Plus, if you're familiar with Mockito's documentation, you might have noticed it even tells you don't mock value objects and instead show love with your tests. So, how do we create our test data, yet minimise our effort? This is where I want to introduce us to the concept of constrained non-determinism. Now, what non-determinism means is we want to create objects with random data, but with some properties constrained to a subset of values. There are of course some libraries out there that can help us with this, such as EasyRandom and JFixture, but none of those mentioned here support some key Kotlin concepts such as null types and default parameter values. And so today I want to introduce you to Kotlin Fixture, which has been built from the ground up with Kotlin in mind. To get started, you simply need to add this dependency into your build.gradle file, and we'll see how we can use it with our example tests. Now, in our example project, we need to create an instance of Kotlin Fixture. And instead of using our factory function, we use that instance to create a movie object. With the breakpoint set, we can see that our movie object is populated with data and even has 5 cast members with data too. Not bad for a single line of code. For testing a cast size of 0, we again use a fixture but need to control the size of the cast list, which we do by setting the repeat count configuration to 0. Similarly, a cast size of 1 just needs a repeat count of 1. Easy. And of course we can repeat the same pattern for a cast size of 2. Repeat count is actually a factory function, so we can use it to generate a random repeat count rather than use a hard-coded value. We're using JUnit 5, so we can use the repeated test annotation to run this test multiple times and adding a print statement we can see what car sizes are generated. Of course, we see the test run successfully with multiple different car sizes. With this particular test though, there's no reason why we cannot generate cast lists from size 0, and repeating the test more times gives us a higher probability of that test case being covered. This then has the added benefit we can remove those first two test cases to simplify things down further. We'll just quickly rename that test so the name makes more sense. There was one test we didn't implement previously, and that was to verify the star rating functionality, so let's implement that now. Here we need to create a movie object, but want to constrain the rating between 4.5 and 5. For that we can use the property configuration. And of course, running that test, we see that it passes. This now means our factory functions are redundant, so let's remove those. And there we have it, our system is tested, and we have used constrained non-determinism rather than hard-coded data. As mentioned earlier, Kotlin Fixture has support for nullable types, and will, by default, randomly return either a null or a random value. Of course, it is possible to override this behaviour to never return null, always return null, or indeed you can write your own strategy to return null when you want to. With default values, Kotlin Fixture will randomly use the parameter's default value or generate a random value. Again, you can override the strategy to always or never use the default value, or provide your own. Another feature Kotlin Fixture has that none of the other libraries out there support is that for abstract classes. If your value object asks for a number, it will randomly generate a byte, double, long, float, int or short, where the other libraries would usually just throw a runtime exception. If you need to, it is possible to force the choice of subclass through the subtype configuration, and in this example a random float will always be returned. As with any tool, there are some best practices that I recommend you follow. Firstly, the constraints used to configure an object should be obvious and help make the purpose of the test clear. Plus, as you want to test as many scenarios as possible, you want to have as few constraints as possible. Secondly, repetition is your friend, as it can help reduce flakiness as well as increasing the number of scenarios you are testing. Of course, you do still have to be mindful of the increased time taken to run your tests, so try to make sure you don't repeat more than you have to. And thirdly, Kotlin Fixture's configuration is immutable. You can share a global configuration and override this where necessary without any risk of weird side effects. Of course, it is nice to see Kotlin Fixture in use in a real-world setting, so let's go back to the Google I/O Shed codebase to discuss how we can improve it. One of the simplest things we can do is automatically generate these speaker classes. First of all, we need to create an instance of Kotlin Fixture. Then we can use that to generate speaker 1. Now the project's tests only rely on the speaker's name, so let's set up a property override for that to keep the data consistent. With speaker 2 and 3, we can simply generate our objects with no additional configuration, since none of the project's tests rely on it. Indeed, the same is also true of room, so let's change that too. And already we've reduced the code needed to generate these objects by 2/3. Not bad for a 1-minute change. Moving on to the session 0 object, it is certainly a lot more complex, with far more hard-coded values. However, this perhaps highlights that the object is being used in too many different tests, and indeed we can see it being used throughout the test suite. Let's now take a closer look at one of those tests. Here, test session is equal to test data session 0. However, at first glance of the code, it is unclear what constraints in the test data cause the expected null result. We can see in its original unmodified state the test passes. Let's start by using a fixture to generate the session object. And rerunning, the test fails as the YouTube event is returned as our constraints are incorrect. Now, all this test requires is the YouTube URL to be provided as an empty string, so let's use the property configuration to set that and rerun the test. And now of course the test passes. However, one thing to note is defining this test data object doesn't make the test easy to understand, so let's copy that fixture configuration into the test. Rerunning the test continues to pass, and hopefully you agree with me that this test code is now far easier to read, understand and maintain with explicit constraints. Kotlin fixture isn't just limited to traditional styles of tests. I've also used it to generate an instance of every serializable class in a codebase to ensure serialization works as expected. If you use parsalize, you may ask whether this matters. Well, parsalize only warns about objects added directly to the parcel not being parsable. If you include a serializable object, and that itself contains something not serializable, then the compiler won't warn you, and instead you get a runtime exception when serialization happens. So you have to be careful when mixing these two types. To test all serializable objects, you create a parameterized test and provide it with a reference to every serializable class in your project. While the code is not shown here, you can use tools like ClassGraph to do this for you. Then it's the case of using Kotlin fixture to create an instance of those classes, serialize the objects using the standard Java APIs, deserialize, again using the standard Java APIs, and finally verify the content of the resulting object matches the original. Of course, Kotlin fixture supports many more features than we've covered today, for example integration with Java Faker to generate more human readable data, or enhanced support to generate any type when using CoTest's property testing. I hope this brief overview has given you a good insight into Kotlin fixture and how to use constrained non-determinism in your tests. For further information, check out the project on GitHub.